All right, everyone. So I'm Rebecca Deck, and today I'm going to talk about my AWS WAF deployment Odyssey, or let's put a happy little WAF right there, as I got roped in yet again to deploying another type of WAF in my long career. So today I'm going to go into a couple of different things. I'll start off with some general information about different types of WAF that you might see. And we'll talk about infrastructure as code to try to level set because it comes important later on. And then we'll talk about why I went with AWS WAF, why the AWS WAF sucks sometimes, the WAF rollout process, how I compensated for some of the issues that we had with AWS WAF, and then how we went through tuning AWS WAF. So first, my bio. I'm a lover of all software developers. So that's one thing that I love about being a product security engineer is I get to work with developers all the time. And I think it's really important to remember that developers are the ones who really run a lot of the company, especially when you're in like fintech type industries, any tech, because they're the ones actually producing the product that the customers want to buy. So being in product security gives me a good chance to try to make sure that they do their jobs just in a secure way and not sit there and be the big department of no that we used to have a long time ago. I've deployed more WAFs in my career than I would like to admit. Pretty much every type of WAF that we'll discuss today is one that I have deployed in somebody's production environment. I've been in tech since like 1995. I worked in QA. I was a software developer. I worked incident response. I was a systems engineer for things like WAFs and web proxies. I was a penetration tester for a few years, and then I did application security. I've been doing that for 6 or 7 years now. I also graduated from the SANS Master's program with my Master's of Science in Information Security Engineering. And I'm not a very good artist, but I have fun drawing, and I had never drawn before like a month ago. It had been since I was in like maybe 4th grade. And it was something that I decided that I wanted to try to do. So I illustrated a lot of the stuff in this presentation myself, kind of badly, but it's okay because I enjoyed it. And you don't have to be great at something to have fun with it. I'm based out of Raleigh, North Carolina, where I live with my wife and my 2 kids and 2 cats. So happy Pride Month, everybody. All right, so let's talk about the different types of WAF. So first, I'll kind of go in what I consider chronological order for most WAFs. So first we had the Inline Web Application Firewall. The Inline Web Application Firewall is one that's traditionally deployed inside a network that you own. The traffic comes into your network, and then you get to see everything that goes in as it flows through the network before it gets to the web servers. Oftentimes you'll terminate TLS on any WAF so that you can get inside that traffic and look at it for certain types of attacks. But the key with Inline is that's going to sit like in that network path. And these are really good because they are very highly customizable. So you have great control over which rules you deploy, what the rules look like, what the regular expressions are, and your caps are really like your ability to or your system's bandwidth, right? When you exceed that system's processing power and memory, that's when you start having issues with applying rules, which gives you generally the most of any of these types of deployment methods. Now, it's also a potential point of failure. So that's one of the things I hate about this. Right? Most of my job is not dealing with WAFs. I don't like being that person that sits there and watches for things and gets called at 2 a.m. By the NOC or something saying, hey, this WAF is down and traffic is stopped to our main line of business. That's not a place I like to be. And when you have this piece of hardware, if it goes down, oftentimes that results in your web traffic going down. Sometimes it's just for a few seconds. We used to run, when I ran physical hardware, we had what's called the ZPHA, zero power high availability. So if the WAF went down, it would switch over to the backup WAF. If that one went down, it would switch over and just pass traffic through. But it wasn't fun to manage that. You always had these upgrade windows that happened at 1 or 2 in the morning when you were allowed to mess with network traffic. It was not so easy to scale because scaling meant buying bigger hardware or more hardware and splitting the load between these different systems. You ran into some weird issues with how the network traffic flowed, if you were seeing responses and stuff like that, that made it not a pleasant thing to deal with. So something I think a lot of companies were glad to get away from. So you had these things, DNS-based WAFs, start coming out. And these I first started running into in like 2014, 2015 timeframe. And these cloud-based WAFs, they're generally some kind of like SaaS solution that sits in somebody else's network. And then a customer wants to know where is your IP address. And the DNS entry they get points them to this Cloud WAF provider. The Cloud WAF provider then terminates the SSL or TLS connection, looks inside it, looks for attacks, and then forwards that traffic onto your servers. And you have to go configure firewall rules on your servers to make sure people don't directly hit your systems and that they always go through this cloud-based WAF. And that buys you some stuff like you can do DDoS protection very easily because you're terminating in somebody else's network. You can, and in like 2015, you didn't have a lot of customization that you could do with that, but it's really improved in the last 6 years. So if you find yourself looking into these kinds of solutions, odds are they've changed if you haven't looked at them in a while. They now provide pretty good ability to customize. I have this specific regular expression that I want to apply to this one parameter on this site, or I want to exclude this one parameter on this one site. And that kind of makes a big difference, I think. So when you look at problems with these, with modern deployment situations, before in like 2015, when I was like, hey, these things are amazing, it was really good because I owned 2/24s and a separate /23 CIDR block space. And when we made systems, we had hardware behind it. They hit a specific IP. The IP address never changed because we were stuck, bound to that static IP. But that's not the case with a lot of modern systems. I see things with blue-green deployments. You're like bringing things up, taking things down, switching traffic over. And it doesn't work quite so well anymore. When I don't control the IP space, AWS does. If that IP changes, you're going to have a bad time because the cloud-based provider, a lot of them, even if you provide like a CNAME record that points to your system, they will not update if anything changes in the background. They still want to go to the specific IP address. They also can have latency issues. So you're going to be sending traffic out to somebody else's system. It's going to be looked at and then sent on to yours. That is probably going to increase your latency somewhat. Now, a lot of these providers say, well, we can actually make your site faster. And that's really great, right? They'll focus on the load time of your website. But websites are not where you really care that much about latency. Most of the time, that's in APIs where I really feel strongly that latency is important, and customers do as well, because you'll have an SLA that you have to meet. I have to respond in 100 milliseconds to this request. Now, if your website adds 100 milliseconds, nobody cares. But if you only had 100 milliseconds to respond to that API and you add 30 or 40, that's a significant penalty that your engineers are going to have to deal with. And it might not be easy because it's going to be written into contracts and they will have to make their systems more efficient. And if it was easy to make their systems more efficient to meet those requirements, they would have already done it. And your SLA would probably be even lower. So you've got to keep latency in mind. They also love to own your network. The cloud-based providers want to own all certificate issuing and all DNS. So if you want to stand up a new website, you would do it at this provider, which is something that I'm not super comfortable with because these sites don't always work. I think it was just a week or two ago, a very large cloud-based WAF provider went down. And when they go down, your site just dies. Nobody can get to it. The management panels for them, you have to be able to access the management panel. So if that ever is gone, you can't go in there and change these rules. You can't claw it back if they own your DNS. And if you don't let them own your DNS, then you're going to have other integration problems because as your IPs change, you won't be able to update them quite as easily. And so now we have the AWS WAF. This is yet another AWS-based service. So AWS is really great at coming out with brand new things that they can sell you. And it's really easy to deploy. If your engineers work in AWS, they probably will have no issues using the AWS WAF. The latency is fantastic because it's sitting right in there, right? You don't have to worry about what that latency is going to be. It was negligible in all of our testing. The problem is their rule sets are not what you see with other cloud providers. You can certainly make your own rules. And I think maybe if you haven't worked with AWS WAF in a few years, 3 years ago, I don't even think they had managed rule sets. You had to specify all the rules yourself. So it was very much a box of nails, and you had a hammer and you had to go find some wood and build all your rule sets yourself. These also contribute to vendor lock-in. It's something we always want to be wary of, because the more stuff that we put in a single cloud provider, the more difficult it is to change away later. And that's where things like Kubernetes and stuff are very useful. But if you go with AWS WAF, you probably aren't going to want to port this to GCP or something, because now you're paying that same kind of penalty where you do traffic routing to the wrong provider. So not super great. Also, billing, when you have something like anything that's these like rate-based types of billing models, like cloud-based DNS is usually also has like a rate-based component. And when you exceed this threshold, then they're like, oh, you're bumping up to the next tier. And when you bump up to the next tier, we'll talk to you and charge you more money. And if you have these weird spikes, they're like, hey, you know what, that's fine. We'll float you this month. It was not a big deal. AWS is not that, especially if you're a small shop. AWS is not someone that's super easy to negotiate with. And if you don't even have like your own, if you're not big enough to have your own dedicated AWS support team, you probably don't even know who to talk to. You just have to pay it. You see these things online if somebody ran a SageMaker tutorial and they ended up with $1,000 bill because they didn't shut everything down. And you can have the same kind of problems with the WAF. And we'll talk about why that billing became so problematic during the deployment. There's a couple of things that I didn't consider that a lot of people do when they're talking about WAFs these days. So IAST and RASP, those I didn't really look at. One, I don't like owning agents. Remember, I don't want to be the one responsible for breaking things. The more I can shift away from me, the more work I can do actually working with developers to do good product security work instead of babysitting some system. But some of our requirements where we had to be able to block attacks, and we weren't going to put agents on everybody's system. These agents get super weird when you're talking about containers and you're talking about EC2 hosts and all these other types of things. You have these various situations that you're going to have to deal with. And the burden for implementing these, as soon as you have an agent, goes onto your engineering teams. It's very hard for me as a security team to absorb that. And a lot of times when we talk about work that security causes teams, one of the things that we strive to do as product security is be this barrier, right? Stopping all this extra work from raining down on the actual engineering team so they can keep doing their jobs. So those were kind of contraindications to these specific technologies. All right, so those are the types of WAFs. Moving into infrastructure as code. Infrastructure as code is nothing more than we can programmatically define the various computer systems that we're using. So I can use a tool like Terraform, I can use CloudFormation, and I can burn down my environment and make it again. I can take this environment that's in US West 2, make it in US East 1, and it just happens. It's something that I love. As somebody who used to do software engineering work, that's a thing that I'm very comfortable with, right? I like the idea that I can write some code. I don't like to be in consoles clicking around on things, because that's how mistakes happen. When I used to do deploys of an old .NET application, I would compile the app on my developer workstation, and I would copy the binaries to the development environment. If the development environment was fine, I copied the binaries from development to production. And that was our deployment process. That's a bad deployment process. The number of times I screwed things up doing that was staggering. So these are the reasons that we don't enjoy that. We like to have code, and the code deploys. The code doesn't make mistakes. It's the same. Unless you've changed it, it's going to operate the same. And you have to like intervene to screw these things up. Another thing I like about infrastructure as code, remember, we try to avoid throwing a bunch of work onto the engineering teams. The more work that I as a security person can absorb, the better the company is going to do. So one of the things that we can do is create these secure templates that are infrastructure as code. We can say, look, if you want to deploy an S3 bucket and you have to do these like 10 steps on an S3 bucket, here's a module that does all these 10 steps. If instead of just directly referencing S3, you reference my S3 module, it will do all 10 steps for you. You don't have to do anything wrong or anything different. And if you find yourself changing any of these defaults that we've set, that probably means you're out of compliance with the standard and you need an exception. So it's very easy to draw that line of telling people what they're supposed to do. And I don't have to hunt them down. They don't have to guess at it. And they don't even have to write their own module. They just say, give me the approved S3 bucket or the approved load balancer and what this looks like. It gives you an audit trail. So all your infrastructure as code, hopefully it's not just sitting on your workstation. Hopefully it gets checked into a code repository like GitLab. And then when it goes to GitLab, that lets us do a bunch of things. I can do a git blame and figure out who did this thing, right? I can check these merge requests and see who merged in a change that broke my stuff. I can also approve things. So it makes it easier for me as kind of a upper level individual contributor to farm some work out to my analysts. So if I have a new analyst and I want them to get used to working in the AWS WAF, I can have them go do merge requests to my library or my repository in GitLab. And when they do those, I have to be the approver on their merge requests. So I can say, yeah, that's an okay thing to do. You haven't compromised the security. You've done something sensible. I can also use Terraform Plan and say what changes will go in here. I don't have to have them in a console with me like shoulder surfing, telling them what to do. I don't like doing that. This is a much more convenient solution for me. And then I can stay consistent through the regions. If I have something built in US West 2 and I want it to be in US West 1 or US East 1, I can just do that. And that's going to become very valuable later on when we talk about how you deploy firewall manager policies in AWS. Same thing if your engineers they have a penetration test coming up, they can just stand up a penetration test environment very easily. So even if your engineers don't do this, you should do it. We often pilot things in our security team and then roll them out to the rest of the organization. That way we can check these things. And there's a reason that engineer is in my job title. But if your engineers already do it, then great. This is you supporting them. You can help them build better systems that are more reliable, more scalable, more secure, that meet your standards. Another good side effect of this, when you write these modules to give to other teams that they need to incorporate into their applications, you don't write stupid standards. If you have something that's not physically possible to do, I think most people who've been in product security at some point have sent out a standard and then teams look at it and they're like, this isn't even possible. What in the world are you talking about? This can prevent us from doing that. Because if I give you two mutually exclusive settings to set on something and I go to try to build that myself and it doesn't work, that's a pretty good indicator that this is not a workable thing for my engineering teams. You can still write dumb standards. We still run everything by our security champions to try to prevent that. But this is just another layer of helping. So next, what have I done? I picked the AWS WAF, mainly because of engineering concerns. It's very important to me not to screw up latency, as you may have guessed from what I said earlier. Some of the DNS-based ones, we were seeing up to 100 millisecond increase, which was a large portion of our SLA to respond to customer requests. Because remember, they're like, oh, we can speed up your site, but that's mainly caching. And caching is going to work by, they have like some edge location. Your content gets cached there. And when somebody requests the same piece of content that's already been requested, it doesn't have to go back to your server, which is great for static content, but it's terrible for dynamic APIs. First off, you can have security problems when you start caching dynamic API content. You can have availability problems where you're giving somebody the wrong information because it's cached. That's a scary thing. I've seen people get somebody else's some kind of like enrollment statement when they enrolled doing something and it was just called this PDF and the PDF was cached in a proxy somewhere and they pulled down somebody else's PDF. So be very careful with those kinds of things. And I might make 1,000 requests in a second to this web API, and they're all going to be different things. So your better off not relying on those kinds of caching things as like a speed savings. These are way easier to use than anything else that we looked at. So we looked at trying to deploy these DNS-based WAFs or an inline WAF. That's not always a trivial thing for the engineering teams to pick up. I can use Terraform, and that's kind of a requirement for our team. We Terraform everything. And I don't like somebody else having a system where if it goes down, I can't control it, because I've been in that situation before, and it always ends with me sitting there by a computer with executives standing right behind me, hitting like refresh on something, just praying that a site comes back up. And that's very uncomfortable for me. I don't like being that person. And the alias record versus CNAME. So alias is a type of DNS record that AWS is the only one who understands. And they automatically update these records in Route 53. And if you're not aware of these updates, you can break the site, because if the IP addresses change, if these names behind your system change, even if you try to abstract them by a layer, it broke most of the DNS-based WAFs. So that was something I didn't want to have to deal with. The engineers would be the ones experiencing the fallout, and they would be calling me at 2 in the morning trying to fix these things. I don't want to do that. Now, the AWS WAF is kind of an interesting beast. So you have these things called web access control lists, and each web access control list has rules and rule groups attached to it. AWS supplies some managed rule sets now that they didn't used to supply. So you can go in and say, give me the core rule set, give me the SQL injection rule set, and bring those in. Then you can apply web ACLs to certain types of resources. Application load balancers, API gateway, only version 1 supports web ACLs at this time. So if you have engineers trying to use version 2, that kind of sucks. Some of it makes a little bit of sense because version 2 can support things like WebSockets, but you can just have like a normal JSON-based API, and you are unable right now to apply web ACLs to it of any kind. You also have CloudFront, and the first two kind of go together. They're what's called the regional policies. CloudFront is a global policy because of the way CloudFront is deployed to try to accelerate things. So CloudFront gets its own type of firewall manager policy, incompatible with the other two. Firewall manager gives you control of this. If you've ever worked in AWS Enterprise, it's an interesting beast trying to manage all these different AWS accounts. They've given you some tools to do it, but it's not simple. Firewall Manager is a great tool that they've added to let you do that. Terraform, when you go to run something across multiple accounts, generally you're going to have to get credentials to manipulate one account, get credentials to manipulate another account, get credentials to manipulate another. And if you have 100 AWS accounts, that's a lot of work. And it takes forever to roll these things out in a manual way. But Firewall Manager lets you say, I'm going to deploy this policy into this security AWS account. This policy will then create web ACLs in all my other AWS accounts. And one of the really cool things that Firewall Manager lets you do is supply tags. So I can say, find any applicable resource. So I can say any ALB or API gateway stage that has a tag of WAF, and the value can be a certain value that's based on the rule set. So you can say, all right, put blocking in there, and it will pick up a rule set that's called blocking and attach it automatically. So that a web ACL called blocking and attach it immediately, which is really handy because your engineers probably work with tags. If you work in AWS and you're not using tagging, I'd like to talk to you about how you're actually managing these resources, because I can't even imagine running AWS without looking at people's tags to figure out who owns this system, what part of where this container belongs, like what system does it even support? These questions are very difficult to answer if you don't have tags. So odds are they're using it for that anyway. And you can just have them add a tag and it will pick up and add the web ACL. So they don't have to manually associate to it. So the engineering lift on this is extremely low with Firewall Manager. But it kind of looks like this. I maintain a security account I have different policies, and these policies say, all right, you need to log to this S3 bucket. So this policy goes out, and it's a US WAF 2 policy, and it will create one web ACL in that account. That web ACL could apply to no load balancers, one load balancer, many load balancers. And then you have a separate one. These are the US East 1 policies. The US East 1 policies go out to US East 1 in all the accounts that you specify. So you can give it a list and say, all right, all these accounts, or you can just say, put in every account that I own. Now, all of these web ACLs will send logs to these buckets in the security account. And the security account will then send that to a bucket in like a centralized logging account. And so then you can, from the centralized logging account, you can farm that off to whatever SIM you're using or wherever you want to stick your logs to actually look at them in a sensible way. You could use Aurora or something, but I wouldn't recommend it. So that's kind of how the WAF architecture looks. But sometimes it kind of sucks, just like MegaMaid. So the policies that you build are per region, right? So in that picture, I had US WAF 2 and US East 1 policies. So this firewall manager system policy will make one ACL per account per region. And so if I had multiple ALBs pointing to a single rule set, one of the cool things that teams are allowed to do is teams are allowed to make their own rules and attach them to my rule group or to my web ACLs. And then those will apply to anything in that region, in that account, which is a double-edged sword. It's cool because teams can say, look, I have this one endpoint that nobody should be getting to because it's for some internal process, or we have a vulnerability and we want to block requests that look like this going to this endpoint. This is great, except now you have to coordinate with any other teams. So if you have the kind of AWS account build out where you say one team gets one rule or one team gets one AWS account, then that's probably not going to be an issue for you. But if you have these big, like, this is my prod AWS account, everything prod lives there, you are unable to roll out very specific rules without rolling out extra firewall manager policies, which gets expensive, as we'll discuss later. But the site-specific rules become complex, and we'll talk about what a complex rule looks like a little bit later and why it's confusing. I never got logging, direct logging to work cross-account. So that's why I have replication set up to move logs from one bucket to another. This uses Kinesis Firehose in the background, and nothing worked for logging using Kinesis Firehose as soon as you turned on at-rest encryption on your S3 buckets, which probably, if it's not a requirement that your S3 buckets are encrypted at rest, it probably should be, because most customers ask about that kind of thing. So I ended up having to use cross-account replication to get the logs to where I needed them to be, which there's definitely going to be some costs associated with moving those logs around. You can't see inside these managed rule groups very well. When we talk about managed rule groups in a little bit, you'll see where these are kind of lacking sometimes in information. Disabling rules doesn't reduce the amount of web content units you use. So every web ACL gets 1,500 web content units that you can put on it. I think you can increase it by contacting AWS. But if you have a managed rule group that has 700 web content units it consumes, and then you take that managed rule group and you say, well, look, this rule false positives all the time, I'm going to disable it. Then you don't recoup those web content units from those rules you turned off. They're just gone. So then if you go to implement that similar rule, you will run yourself out of web content units, which is kind of sucky, right? And oftentimes you're going to turn off a lot of rules when you're doing tuning with the AWS WAF. And we'll talk about that in just a second. And then you have the CloudFront versus regional policies we already talked about. The rules are super aggressive, super aggressive. We got false positives on just about everything for specifically like cross-site scripting and SQL injection. Anything, if it was a post request with a PDF, somebody was uploading a PDF, there was no way that was going through. It always blocked it. XML and HTML tags, came across as cross-site scripting almost all the time. And yeah, it does look kind of questionable. I could see where it would match cross-site scripting, but there's no way to say, here's a rule for cross-site scripting in this XML document. It's not going to happen. You'd have to write some custom regular expressions that you do that with. Base 64 encoded stuff tripped all kinds of rules. And so if you have a lot of base 64 encoded content, those default rules will probably give you some heartburn. They block things like no user agent header. I was like, well, that's kind of a silly one, right? I don't want to be responsible for doing that, because we have a lot of APIs, and when people request APIs, maybe they don't send a user agent header. That's okay. They're not using a web browser. And then we have size restrictions. That's impossible to know across your organization. I don't ever want to be in the position where I'm managing size of requests coming across to my engineers. That's something that they should own. I don't want to be there for them breaking it, because even if I'm right today, they would have to coordinate with me if they want to increase their request size in the future. You don't want to be in that business. So me making this, it was not a fun experience for me. Our team always uses infrastructure as code. So we use Terraform to build this out to match what engineering does. We definitely went with the AWS Firewall Manager. It was so much easier for engineers to onboard with Firewall Manager, and so much easier for me to manage these rules that I can't imagine trying to do this without it. It would not go well. And I like the idea that I could run all my rules for one region in one place, and then it went out to every account, and I didn't have to sit there and micromanage it. So this gets kind of expensive, though. It was $100 per policy per month. Talk about where that got a little ridiculous. But I like the idea that teams could make their own rule sets and then attach them to that web ACL without overriding central policy. So there is no way for them to say, oh, except for this request, allow this request, because then you have to worry about teams punching holes in your rule set. So I liked the idea that I didn't have to worry about that. With any AWS policy, like AWS is great because it's always making new things. But when you try to use a new thing that AWS puts out, like version 1 of things is sometimes rough. It's not going to be fully supported and fully baked by the time you start working on it. If you're like, oh, hey, this new thing just dropped, let me start using it in production, it may not go super great for you. And Firewall Manager was too new for good support for infrastructure as code. So Terraform had 0 support for Firewall Manager policies when I started doing this project. They do now. So instead, I was like, well, let me use CloudFormation. AWS makes CloudFormation. Surely this will work properly. And it worked perfect for ALBs. But as soon as I tried to add API gateway support, it did not work. So that specific, it would just say that's an invalid target. So you couldn't do that. The AWS command line did work. So I could take the same JSON that I would have put in there through CloudFormation, and I could run that from the command line, and that worked just fine. So what I did was I had to phone a friend. My friend Io came and helped me and helped me write some Terraform that generated the JSON that then I could use the AWS CLI to push up to AWS and push my rule sets that way. But it generated one JSON file per policy per region. So if you had 10 policies and 10 regions, you had to go run 100 CLI commands to push that out. So I started working on a Go script to do it. But when I was working in Go, or Go program to do it, when I started working in Go, they actually came out with Terraform support and completely obviated the need for it. So that's something to keep in mind when you're working with these brand new solutions. You might go off on this tangent automating this stuff because you're like, oh, well, it doesn't do this thing. And AWS knows it doesn't do that thing. Or Terraform, somebody's got like a merge request in to the main Terraform line to get support for that in the provider. So keep in mind, before you go down a rabbit hole doing a ton of automation in AWS, you may not need to do that if it's going to take you 3 months to implement and roll this out, and AWS is going to have support in 2, well, then you just wasted your time. We also ran into a weird bug with orphan policies. So the policies would get created. And then when you went to go push a new version of the policy, it would delete the policy, but none of the associated web ACLs. And you would keep getting charged for those web ACLs, which no longer had rules and could never be deleted. So we had to contact AWS and have AWS delete those. I don't know what you do if you don't have like high tier AWS support with your people helping you out. You'll probably never be able to do it. So something to be cognizant of. Hopefully they fixed that by now. But I really like the ability to apply firewall manager policies using tags. It was so easy, and I didn't have to worry about drift with people modifying my stuff. I could control it all myself. If I wanted to, I could have built that myself using Terraform and Lambda functions, trying to save money, but that would have been a very unpleasant experience. So next we have complex rules. So when you look at AWS rules, the GUI for them is not great if you want to do something very specific. You can make these rules and you can use and, or, and not. Well, you can use and, or not. You cannot use multiples of these at the same time in the same rule. It will not work in the GUI. But if you want to hand jam out some JSON, you can do that. So that's what I ended up doing, because it's all JSON to me anyway, because I'm going to have to put it into Terraform. But you can go in and start building out your rule in the GUI, and then switch over and look at the JSON in the GUI and copy that out, and then add in your nested statements. And then you can write more complex rules. But some of the examples for these would be source IP is not in this IP list, and the body has some kind of text in it. That might be something that we want to block. So only certain IPs are allowed to send these kinds of requests to this system. And that is not something you can do in the GUI. You have to do that with JSON. And that really became common with nots, where you wanted to exempt a specific parameter or a specific type of request from that, specific endpoints. So this is what the other part was. So this was like one continuation. So you can do that first part, you pick and then you get the second part, but there's no way to pick a not on the second part. But if you pick JSON, this is what it transforms into. You can take that out, and then maybe I want to stick a not in front of this statement, and I can certainly go do that and nest these all I want once you're in the, well, I haven't found a limit yet of nesting inside the JSON. But then it's artisanally handcrafted JSON, and that's not fun for some people. We had to do some billing hacks on this. So if you have like 10 policies you want to push out, and you have 5 regions that you're using in all your AWS accounts, and each one of those is going to be $100. That's $5,000 a month just in the FMS policies, not data transfer or web ACL costs. Now, if you have 10 non-blocking and 10 blocking rules and 10 regions, now you're looking at like $20,000 a month just in the firewall manager costs, which is brutal, right? And some of these, like, people may not even be using certain regions. And if you push stuff out there, now you're paying this. So if only certain teams are using certain regions, you can't get a lot of cost savings there. So that got really expensive really fast. But Shield Advanced, so if you subscribe to Shield Advanced, their DDoS mitigation thing, then the licensing or the cost becomes a little more friendly, because yeah, you'll get transfer costs by applying Shield, but you save on these kind of WAF rule costs. You can associate these FMS policies and web ACLs with Shield Advanced. And when you do that, they're supposedly free, right? Or you aren't paying for that specific firewall manager policy. I'm still validating that one, but that is the word that I got from the AWS team. And you can go look, they have an Amazon blog that they put out on how to estimate this stuff. That would have been super helpful if it had existed when I started doing this. And then WAF tuning. So all WAFs are going to be garbage when you first turn them on, everything. When you start rolling these out, I highly advise doing non-blocking on your production systems. So what I had teams do was roll out a blocking rule set for their lower environments, and then all teams hopefully have good integration tests. So they will turn on blocking in a lower environment, run their integration tests, see what gets blocked. If they block something, then I have to go look. It's probably going to be a false positive because it's from their functional integration tests. I need to go and figure out what to do about that. Some things to keep in mind: make sure you know who owns what apps. That's critical control number one on the CI's critical controls for a reason. So then you go and look at prod. Once you get through and all their integration tests pass in the lower environment with blocking rules, put non-blocking in production. Then look at what production does. See what's happening. Don't block in production yet, because sometimes integration tests are not complete. So you want to see what customers are doing that's different from what's actually happening on your integration tests, which is a good opportunity to improve your integration tests too. But then I would take like the top events and the bottom events. So top ones by volume, and say, look, I've got like a ton of these coming in all the time. These are probably going to be false positives because there's so many of them, unless I got like a scan or something. And then bottom events, go and do like long tail analysis. And you say, well, this is like a weird thing that's happening on this site. So I picked a couple a day and go through those. Then you either disable that rule and come up with a compensating rule, or you take that rule and tune it. Some metrics that I found to be helpful for WAF adoption, or WAFs, I have two phases for any time I roll out something: adoption and efficacy. So we want to make sure people are using the thing. Then we want to make sure the thing is working. So the adoption ones are all around, is somebody using this? Are they blocking? Are they doing whatever? Traffic flow, I want to know, because if my traffic flow just drops off, odds are something is broken. If my traffic flow goes way up, maybe somebody onboarded a new site. Right? So you got to look at that though and figure out what's going on here. Efficacy. So then you want to make sure this thing is actually working. And you might say, Rebecca, how do I know if something's false positive or true positive or it's false negative? How am I going to know a false negative because I didn't alert? Well, this data should come from your CERT, right? When your incident response team goes to respond to something, and they're like, oh, this was a false positive. Now you have normalized that data. If there were 100,000 requests that were all false positive, that becomes one incident they investigated that was a false positive. If they investigated it and it was a true positive, that becomes one true positive. Great. If it was a false negative, so if they were handling an incident and they said, gosh, if the WAF had only been tuned right, this would not have happened. We wouldn't have had this incident. And that's super valuable because now you roll that in, continuous improvement, build a new rule, and make sure you don't make that mistake again. And then you should see false negatives and false positives dropping off over time and true positives going up. So that's what your metrics should look like. Some example logs that we have here. So this is what an AWS log looks like. It's horribly unfriendly, but you have something like, in this case, we had to disable the SQL injection, and that's why this argument didn't trip it. But you can see here, it made it through the default action, and that was to allow this request. If we go over here, we have action of blocking. So here, this means that that request was not permitted. Then you have to look for terminating rule. Then you look for the rule ID. Is this bad bots header? So that way we know what rule tripped it. And the bad bot header, I can go look at the user agent header and see what it was. And they were using zgrab. So that's probably a true positive that should have been blocked. For cross-site scripting blocking, this is what it looks like. And SQL injection is going to look kind of similar. So you get a terminating rule with a block, terminating rule match detail. So this is, why did this block this request? It says, I found XSS in the body of this request, and this is the specific string that made me upset. You can't see what the regular expression was that tripped this. You cannot disable this, or you can't manipulate that regular expression. All you know is AWS decided this had cross-site scripting there. And you can see that it specifically tripped cross-site scripting body. So if you wanted to permit this, then you would have to go in and disable cross-site scripting in the body, which is something that made me very uncomfortable as a security person, saying, all right, I'm not going to check for cross-site scripting in the body of any request going there because it tripped on this one PDF or this one XML request that went up. That's something that's really tough to swallow. So then you kind of have to go and write your own rules that are specific to that. And this is where your costs really start ballooning, because you're like, well, these other sites seem okay with this rule, so I won't disable it there. But now I have to have a second FMS policy. I have to have that policy in non-blocking and in blocking so people can test their stuff. And that's where your cost really starts tacking up, because you end up with 20 different policies with blocking and non-blocking. Now you're spending tens of thousands of dollars every month on this. So that's why you have to kind of use that Shield Advanced trick to get through it. And you can also see here, it tripped the excluded, I had excluded this as count, the generic RFI. So this was also listed as remote file inclusion. It did not like that string one little bit. But that's kind of how it goes with tuning. You got to go through those logs, figure out what happened, figure out false positive, true positive, and then tune the rules appropriately, and then get all that. A lot of that information should be coming from your cert team. So here's my happy little tree. But remember, engineering is more important than you as a security person. It is one of the fundamental tenets, I think, of product security. You need to be helping them. We shouldn't just be a cost center, or our only value is in like marketing that we're the most secure, or that we're going to like stop the bad guys, right? We can actually help the business. We can write modules. We can make things that are easy for engineers. We want to make it easy to do the right thing with security. So keep that in mind when you're looking at how you run product security in your organization. WAFs can be useful. I've stopped a lot of really good attacks from coming in. You say, oh, we know that we have this vulnerable software component. This is what the exploit looks like. I'm going to go in, write a WAF rule to block it on this system. Or I want to start doing detection when this is being used against me. When you start automating stuff in AWS, stuff gets super weird. Yeah, so stuff gets super weird when you start automating stuff in AWS, because AWS might come along and take that away from you. Like they might do this for you in a much better way. Granted, they'll probably charge you for it, but you may not need this huge like Rube Goldberg machine of stuff that you just like strung together to get stuff done. Watch out for costs. Anytime you're using AWS, be super careful about your costs and make your decisions deliberately. People should be going into this with their eyes wide open for how much money they're going to spend. And then also, I had fun doing my art, even though I'm not good at it. But you can enjoy things that you're not great at. So keep that in mind with the pandemic, right? Things are winding down, but you don't have to be amazing at something to have a good time. And that's pretty much it. I can stay in and look for questions in just a second. I don't see any in the Track One Discord channel, but I'll be on there if anybody has further questions. So thanks everyone for your time.